Welcome to Solving One-Step Equations with Multiplication and Division. I'm Mr. Pi, the math guy. You have to remember when solving equations, and we're talking about some very simple equations today, but the goal is to isolate the variable. When isolating the variable in an equation, you want to consider that you have a left, a right, and the middle of an equation. To give you an idea how we're going to achieve this goal of isolating the variable and using the idea of left, right, and middle, I have a simple equation right here. 3x is equal to negative 24. Now, to understand equations and the terminology I'm going to use in my videos, you have to understand that the equal sign is the middle of the equation. And for this particular equation, we have 3x on the left-hand side. So for this particular equation, the variable is on the left-hand side. And on the right-hand side, we have the constant number, negative 24. Not all equations are always going to have the variable on the left. A lot of times they do, and a lot of teachers teach you when you get into multi-step equations to get the variable on the left-hand side, so it's easier to solve once you get it down to 2 steps. So anyway, I hope you enjoyed the video today on solving one-step equations with multiplication and division. It's very interactive. Solving one-step equations, here we have some properties of equality. The first one we're going to look at is the multiplication property of equality. For all real numbers a, b, and c, if a is equal to b, then a times c is equal to b times c. In essence, what that means, that whatever you do to the left side of an equation, you have to do the same exact thing to the right side of an equation. If you watch my video on solving one-step equations with addition and subtraction, then you would understand that the idea is equations are like a seesaw or a balance scale, or whatever, to keep the balance, we have whatever we do to the left, we have to do to the right. Here we have a basic division fact. 14 divided by 2 is equal to 7. The two sides are equal, but they don't look equal. What I'm going to do is multiply both sides of this equation by 2. And what you're going to see, I'm using the multiplication property. On the left-hand side, since we can view this as 2 over 1, the 2's in the numerator and the denominator, they divide out because they end up being common factors. So on the left of the equation, we're left with 1 times 14, which gives 14, and 1 times 1 in the denominator, which gives 1, and 14 divided by 1 is just 14. And on the right-hand side, 7 times 2 is 14. So we can see there with a numerical answer that the use of the multiplication property of equality can change equations, but yet maintain the equality of that equation. For the division property of equality, for all real numbers a, b, and c, if a is equal to b, then a divided by c is equal to b divided by c. In other words, whatever you divide the left-hand side of the equation by, you have to divide the right-hand side of the equation by. In my numerical example here, I have 3 times 9 is equal to 27. That's a basic multiplication fact that you should know. To make both of these things look the same, I can divide each side by 9. The 9's on the left divide out because they're a common factor. In fact, what they do is they leave a factor of 1. So you have 3 times 1 in the numerator to leave 3, and just a 1 in the denominator, so that'd be 3 over 1, which we can simply write as 3. And on the right-hand side, 27 divided by 9 is 3. So again, using another property of equality, we can divide each side by the same number and not change the value of the equation at all. We're going to see how that works when we're trying to isolate a variable. Solving one-step equations with division. As implied by the title of the slide, we're going to be solving equations with division. We're going to have a little explanation first. In problem number 1, we have 2x is equal to negative 26. A lot of students get lost here because they forget the meaning of saying 2x. It really means 2 times x, or 2 multiplied by x, and the inverse of multiplication is division. So what we're going to do here is divide each side by 2, and we're using the division property of equality here. When we divide each side by 2, 2x divided by 2 on the left of the equation, that cancels out and leaves us with 1x on the left-hand side. We traditionally don't write that 1 in front of the x. A coefficient of 1 is not needed. Negative 26 divided by 2 is negative 13. You probably should be able to do that in your head. If not, you could use a calculator, or you could use long division. What we can do here is we could check our answer real quick, and if everything's done right, this works out pretty easy. So what we do is we substitute our solution, negative 13, into x in the original equation. So we have negative 13 in for the x. So we have 2 times negative 13 is equal to negative 26. And multiplying this out if you need to. 2 times 3 is 6. 2 times 1 is 2. And that gives us a negative 26 because a positive times a negative is always negative. So our work does check out for that first problem. There you should see and notice that we used the division property to divide each side by 2. And problem number 2, reading it, it's negative 5 times x, or negative 5x, is equal to 7 and 3 tenths. We're going to, again, use the same property, the division property of equality. We're going to divide each side by negative 5. On the left-hand side, the negative 5's, they divide out, leaving 1x. And on the right-hand side, we have some basic math to do. We're going to rewrite this as 7 and 3 tenths divided by a negative 5. Now, as you probably learned in a basic math class, to do this, we first need to convert this mixed number into an improper fraction. 10 times 7 is 70, and 70 plus 3 is 73, so that gives me my numerator. I went 10 times 7, and then added that, 70, to the 3 to get 73. That's my numerator, 73 over 10. And on the right-hand side of this little expression, instead of division, we're going to be putting multiplication, and we're going to multiply that by the reciprocal of negative 5, which is negative 1/5. If you imagine negative 5 is a fraction, negative 5 over 1, that would be the reciprocal, or the inverse. Before we get our final answer, we're going to multiply the numerator. 73 times 1 is 73. And 10 times negative 5, well, that gives a negative 50. We're going to put that negative out front. And that could be our answer, a reduced improper fraction, since 73 and 50 do not have any common factors. We could write this as a mixed number. Since 50 goes into 73 one time, that would be a negative 1. That would leave us with 23 left over, so negative 1 and 23/50. So either one of those could be our answer. If we go into our check mode here, just to make sure our answer is correct, we're going to substitute our solution into the original equation. The original equation was negative 5x, or times x, so we're going to multiply that by our solution. I'm going to use the negative 73 over 50, the improper fraction. And that should be a 73, not a 75. And that needs to be equal to a positive 7 and 3 tenths. So on the left-hand side, we'll do some multiplication. If you need to put that over 1, you can, that negative 5. And here, before we multiply numerator to numerator and denominator to denominator, we can cross-cancel across this multiplication. We can use a factor of 5. 5 goes into negative 5, negative 1 times. And 5 goes into 50, 10 times. So we're going to be working with these new numbers. Negative 1 times negative 73 gives us a positive 73. And 1 times 10 gives us 10. And so we have the improper fraction, 73 over 10, being equal to 7 and 3 tenths, which we know, of course, is true. 10 goes into 73 7 times, with 3 left over. So our work does check out. And our last problem, problem number 3, The only real difference between problem number 3 and problem number 1 is that we have a decimal. Negative 6/10 x is equal to 42. To solve this equation, since it's multiplication, we're going to divide each side using the division property of equality by negative 0.6. On the left-hand side, the negative 0.6 is divided out, leaving us with x, thus achieving our goal of isolating the variable. On the right-hand side, we have to divide 42 by negative 0.6. Well, as you should know, division by decimal isn't allowed, so what we do is we have to multiply both these by 10. 42 multiplied by 10 is 420. Negative 0.6 multiplied by 10 is going to give me negative 6, and 420 divided by negative 6 is a negative 70. So that's our solution. Moving into our check mode, we substitute our solution, negative 70, into our original equation. Negative 0.6 times negative 70, and that needs to be equal to a positive 42. When we do this multiplication, negative 0.6 times negative 70, 6 times 0 is 0, 6 times 7 is 42. Since 6/10 has one decimal place, our decimal starts at the right at 420, moves to the left one time, giving me 42 is equal to 42. So the work does check out. Solving one-step equations, your turn. What you should do at this point is pause the video, and probably should time yourself. Shouldn't take a whole lot of time to do these problems. Maybe at most I'd say 10, 12 minutes. When you're done, what you should do is unpause the video to continue the video and get the solutions with the work to make sure your work matches back to the video from solving the problems. In problem number 1 on your turn, we have negative 3x is equal to 45. So what you need to do to solve this problem is divide each side by a negative 3. And when you divide each side by a negative 3 using the division property of equality, the negative 3's on the left-hand side, they cancel out, leaving you with x is equal to, and then doing this division either by hand, long division in your head, or with a calculator. 45 divided by negative 3, well, that gives you a negative 15. Hopefully you checked your work and you know that works out to be the correct answer. In the next problem we have negative 6x is equal to 12 and 3/5. What we'll do for this particular equation, since it is a multiplication with the variable x on the left-hand side, we'll divide each side by negative 6. As I modeled in the first part of this video, on the left-hand side, the negative 6's is going to divide out, leaving you with 1x. On the right-hand side, we're going to rewrite this as 12 and 3/5 divided by negative 6. And how we're going to solve this from here is we're going to change this mixed number into a improper fraction. 5 times 12 is 60, and 60 plus 3 is 63. So this 12 and 3/5 as a improper fraction is 63 over 5. And we're going to multiply that by negative 6's reciprocal, which is negative 1 over 6. Before we multiply our numerators, we're going to check for common factors in the numerators and the denominators. 63 and 6 have a factor of 3. 63 divided by 3 is 21. And 6 divided by 3 is 2. There are no other common factors, so I'm going to multiply the numerators. 21 times 1, that is equal to 21. And then 5 times 2, that is equal to 10. A positive times a negative is a negative. And I can write that as a mixed number, 2 and 1/10. If I were so inclined, I could write that as the decimal number, negative 2.1. So either one of these would be an acceptable answer, I think. You have to be aware of that too, that these are all acceptable answers. In problem number 3, we have negative 4/10 x is equal to 8 1/10. To solve this problem, since we are multiplying with the variable negative 4, or negative 0.4x, we're multiplying negative 0.4 by x, we're going to divide each side by negative 0.4. On the left-hand side, the negative 0.4's cancel out, leaving 1x. The variable is now isolated. 8 1/10 divided by negative 0.4. We are going to multiply both of those numbers by 10, so we end up with 81 divided by 4. Actually, would be a negative 4. Doing that division, this is how you would do it with long division. 4 goes into 8 2 times. 2 times 4 is 8, so that leaves nothing left over. I bring down my 1. 4 does not go into 1, so I put a 0 in here as a placeholder. After I put a decimal in, put a 0 in, bring it down, and 4 goes into 10 2 times. 2 times 4 is 8. Subtract, get 2 left over, add a 0, bring it down, and 4 goes into 20 5 times. So we get the decimal number, 20.25. So you saw me there, find the answer as a decimal. I can write that answer as a mixed number now. And that should be a negative because it was a negative 4. So it should be x is equal to negative 20.25 or negative 20 1/4. Or as I had up here initially, negative 81 over 4. So either one of these would be an acceptable answer. Solving one-step equations with multiplication. In these problems 4, 5, and 6, what we're going to do is use the multiplication property of equality, which states that we have to multiply both sides of the equation to maintain equality. So in this problem, if we read it, x divided by 7 is equal to negative 4. Since x, the variable that's on the left-hand side of the equation, is being divided by 7, we perform the inverse of divide by 7, which is multiply by 7, using the multiplication property of equality. We do it to both sides. On the left-hand side, if you imagine this as 7 over 1, the 7's can cross-cancel, dividing each of those 7's by a factor of 7. In essence, they divide out, but we're dividing it by 7, so we get 1 times x to give us x on the left-hand side, and we have achieved our goal of isolating the variable. We have 1x on the left-hand side of the equal sign. There's our equal sign, and on the right-hand side, we have to do negative 4 times 7, and that's a negative 28. 4 times 7 is a basic multiplication fact, and a negative times a positive is always a negative. If you want to, you can check your work here. We would check that work by substituting the solution, negative 28, into the original equation. Negative 28 divided by 7 is equal to negative 4. And in fact, that is true. 28 divided by 7 is 4. A negative divided by a positive is always negative, and that is equal to negative 4. So our work does check out there. In this problem, number 5, x divided by negative 3 is equal to 5 1/3. The only real difference between problem 4 and 5 is the fact that on the right-hand side we have a mixed number, not an integer. So to solve this problem, on the left-hand side, x, the variable, is being divided by a negative 3. So we'll multiply each side by a negative 3. The negative 3's on the left-hand side divide out. They cancel, if you will, leaving us with the variable now solved for, x, being equal to. Now on this side, we have to multiply this mixed number by this integer. We'll change this mixed number into a improper fraction. 5 times 3 We multiply those two, that gives me 15. And then 15 plus 1, that gives 16. That'll give me 16 over 3 times a negative 3. A couple ways you could do this. You could multiply and then divide out, or you could cross cancel as I did in the previous example. And in the previous example, I had to cross cancel 7s. In this case, it's a 3 and a negative 3. They're both divisible by a factor of 3. So that would 3 divided by 3 gives 1. And then negative 3 divided by 3, well, that gives us a negative 1. Then we multiply numerator to numerator, 16 times negative 1. That gives negative 16. And 1 times 1 gives us 1. And negative 16 over 1 is the same as negative 16. So our solution here is x is equal to negative 16. We could check our work by substituting negative 16 into the original equation. So here comes our check. Negative 16 over 3 is equal to, and actually be a negative 3, is equal to a 5 1/3. And in fact, that does check out because our solution, before we multiplied, ended up being 16 over 3. So negative 16 over negative 3. The answer is going to be positive. 3 goes into 16 5 times. The denominator of the fraction is 3. And there's 1 left over because 3 times 5 is 15. That would be 1 left over. So this problem does check out. What I should say is this solution does check out. Number 6, what we have to do is solve the equation x divided by 1.25 is equal to 7. Since the variable is being divided by a number, we're going to multiply each side by that number that is doing the division, or in the denominator, or below the variable. So multiplying each side by 1.25. The 1.25s on the left-hand side, they cancel out. They divide out, leaving us our goal, x, the variable now isolated. On this side, we have to multiply 7 times 1.25, so I can do that work right here. 7 times 5 is 35, carry the 3. 7 times 2 is 14, plus 3 is 17, carry the 1. 7 times 1 is 7, plus 1 is 8, and I'm going to have to move the decimal 2 times, starting at the right, once, twice, to get a final answer of x is equal to 8.75. Once again, we can check our work by substituting 8.75 into the original equation. So 8.75 divided by 1.25 is equal to 7. And we can do that division. 8.75 divided by 1.25 again, with decimals in division, you have to make this a whole number. In essence, by moving that to the right 2 times, that decimal to the right 2 times, I multiply that number by 100. I do the same thing in here. So I'll be dividing 875 by 125, and that actually does go 7 times. 7 times 5 is 35, carry a 3. 7 times 2 is 14, plus 3 is 17, carry the 1. And 7 times 1 is 8. So when we subtract, we get nothing left over. So the left is equal to the right. So the solution, x is equal to 8.75 or 8 3/4, does check out. Be ready for the interactive part of this video lesson coming up next. Solving one-step equations, your turn. As you saw in the previous examples, I used multiplication to solve the equations. What you're going to do is use multiplication to solve these 3 equations. You should pause the video and time yourself. I'd say about anywhere from 6 to 10 minutes should be a sufficient amount of time. When you're done, continue the video and then you can get the solutions to your work. So pause the video starting now. Welcome back. Hopefully you got all these problems right. Let's take a look at number 4. In number 4, it's x divided by negative 12 is equal to 6. Using the multiplication property of equality, you're going to multiply each side by a negative 12. Now remember, the negative 12s on the left-hand side of the equation, they divide out. They become 1, leaving us with 1x. On the right-hand side, we have to do 6 times negative 12. Positive times a negative is a negative, and 6 times 12 is 72. Now, 6 times 12 is a multiplication fact that you should know, or you should be able to complete that multiplication very easy. It's 2-digit by 1-digit. Problem number 5 is x divided by negative 5 is equal to 4 3/10. To solve this problem, we're going to multiply each side by a negative 5. It's because we have x divided by negative 5 on the left-hand side. Now, on the left-hand side, the negative 5's cancel out, leaving us with x. On the right-hand side, to complete this computation, what we have to do is change this 4 3/10 into an improper fraction. 10 times 4 is 40, and then we go 40 plus 3 to give us 43. The numerator will remain 10. And on the right-hand side, we're going to express this as negative 5 over 1. We can cross-cancel the negative 5 and the 10. The common factor is 5, so we'll divide both of those by 5. 10 divided by 5 leaves 2, and negative 5 divided by 5 leaves negative 1. So in essence, we have 43 times negative 1 to give negative 43, and 2 times 1 to give 2. We could leave our answer as an improper fraction, or you could change it to a decimal. 2 goes in, well, it'll be negative because it's a negative divided by a positive. 2 goes into 4 twice with no remainder. 2 goes into 3 one time with 1 remainder, so that would give us negative 21 and 1/2. Or, if you wanted to express that as a decimal, negative 21.5. So any one of these three, if you came up with it, would be an acceptable answer. In problem number 6, we have x divided by 2.5 is equal to negative 12.5. To solve this problem, since on the left-hand side we have x divided by 2.5, we'll multiply each side by 2.5. On the left-hand side, the 2.5's, they do cancel out, leaving us with 1x. And on the right-hand side, we have to do the arithmetic. 12.5 times 2.5. A negative times a positive is a negative. And I'll set this multiplication up by putting the 2.5 under the 12.5. I'm going to need to move this down a little bit. 5 times 5 is 25. Write down the 5, carry the 2. 5 times 2 is 10, plus 2 is 12. Write down the 2, carry the 1. And 5 times 1 is 5, plus 1 is 6. Moving on, 2 times 5 is 10. Carry the 1. 2 times 2 is 4, plus 1 is 5. And 2 times 1 is 2. Add these two together. 5 plus nothing is 5. 2 plus 0 is 2. 6 plus 5 is 11. Carry the 1. And 2 plus 1 is 3. So the answer here, 3125. Now we have to put the decimal in. 12.5 has 1 decimal place, and 2.5 has 1 decimal places. So that means our answer is going to have 2 decimal places. So the answer is negative 31.25, or negative 31 1/4. 2 ways to write the same thing? What? Are you serious? Isn't math hard enough already? Well, much like the English language, math has 2 ways to express the same thing sometimes. So let's take a look at how to do that. Let's take a look at how these 2 expressions are the same. If we just move them around a little bit and kind of place them on top of each other, we can see they both have a 3 in the numerator and a 5 in the denominator. So if you're taking notes, you might want to write that down. If not, it's cool. but they have a 3 in the numerator, and they have a 5 in the denominator, and they also have an x. So that's how these two expressions are the same. Now, let's compare how they're different. Looking at them, we can see there's a 3 in the numerator. We already talked about that, but there's also an x in the numerator, one of them. And that's the really only way that they're different, is that there's an x in the numerator of the 1. That's their only difference. In essence, what you have to understand is these two things are basically the same. A lot of students have trouble with these things, and these things are called fractional coefficients. Coefficients are defined as numbers being multiplied with a variable, and 3/5 x and 3x over 5 in essence are the same thing. They involve a fractional coefficient. They're just written slightly differently. And the upcoming examples are going to help you learn how to solve and deal with fractional coefficients. Solving one-step equations with multiplication. The title of this slide isn't exactly accurate. We can solve these with multiplication, or we could solve them with multiplication and division. I'm going to show you how to do that here. I'm going to show you both ways. And the two ways to solve these equations would be by first multiplying both sides by the reciprocal, or you could multiply, then divide. I'm going to show you first how to multiply by the reciprocal. So here in example 7, we have 2/3 times x is equal to 12. To solve this equation, we can multiply each side by the reciprocal of the fractional coefficient. The reciprocal of 2/3 is 3/2. Now, if you're not familiar with the word reciprocal, you may be familiar with the word inverse or multiplicative inverse. Using the multiplication property of equality, I multiply both sides by the reciprocal of the fractional coefficient. Now, the reason we choose to multiply by the reciprocal is because we can cancel or divide out all of the numbers on the left-hand side, leaving us with 1x, achieving our goal here of having 1x. On the right-hand side, we have 12 times 3/2. Now, we can go 12 times 3 to get 36, then divide that by 2 to get 18. Or we could cross-cancel, imagining that we have 12 over 1 here. 2 divided by 2 gives us 1, and 12 divided by 2 gives us 6. By cross-canceling, we reduce beforehand. 6 times 3 is 18. 1 times 1 is 1, so 18 over 1 gives us 18. Now I want to show you how to solve that equation with the other method. Put this problem aside for a moment. We'll get to that in a second. Now, what I did here is I multiplied by the reciprocal, or multiply by the inverse. The second method I'm going to show you is going to involve a combination of multiplication and division. I'm going to do it in 2 steps instead of just 1. So we have here is 2/3 x. It's the same problem, just going to show you a different method, is equal to 12. Now what I'm going to do is multiply both sides by 3 first. That'll cancel the 3's on the left-hand side, leaving me 2x, or 2 times x. And on the right-hand side, 12 times 3 is 36, not 13, it's 36. Next, I'm going to divide both sides by 2. which is going to leave me x on the left-hand side equal to 18. And what I did here is I did 2 steps instead of just 1. You can multiply by the inverse and do it in 1 step like I did here on the left, or you can multiply by the denominator, then divide by the coefficient that's left in front of the x. Let me show you this other example. It does look a little bit different, but it really isn't much different. Take a look at this example 8. It's actually pretty easy. We can do it with 1 step since we have 4x over 5. We can multiply both sides by the reciprocal of 4/5, which would be 5 over 4. Using the multiplication property of equality, we multiply both sides by 5 over 4. The 5's divide out on the left-hand side. The 4's divide out on the left-hand side, isolating our variable of x. On the right-hand side, we can cross-cancel. 4 and 26 have a common factor of 2. 4 divided by 2 is 2. 26 divided by 2 is 13. So then I can multiply what's left in the numerator, 13 times 5, which gives 65. And what's left in the denominator, 1 times 2, is 2. We could leave our answer as an improper fraction, or we could change it to a mixed number. 2 goes into 6 3 times. 2 goes into 5 twice with 1 left over, so that'd be 32.5. Or as a decimal, 32.5. You could have solved this problem with the other method. Instead of multiplying by the reciprocal, we could have multiplied both sides by 5 and then divided both sides by 4, and we would have arrived at the same result, 65 over 2 or 32.5. The interactive part of this lesson is coming up. We have some problems for you to do. Solving one-step equations, your turn. In the previous example, 7 and 8, I showed you 2 different ways to solve equations that had fractional coefficients. You can either multiply by the reciprocal, or you could multiply both sides by the denominator, then divide both sides by the coefficient that is left in front of the x. What you're going to do is pause the video and time yourself anywhere between, I'd say in this case, 4 to 7 minutes. It should be sufficient. When you're done, unpause the video and get the solutions and check your work. Welcome back. Hopefully you got both of these problems right. Let's take a look at these solutions. In number 7, we have 15 over 16 times x is equal to 50. We're going to use the method by multiplying each side by the reciprocal here. We're going to multiply each side by 16 over 15. Remember, on the left-hand side, the 15s and the 16s will divide out, leaving us with 1x. Thus, our goal has been met, isolating the variable. On the right-hand side, if you imagine 50 over 1, we have to multiply 2 fractions. 50 and 15 have a common factor of 5, so dividing 15 by 5 gives 3, and dividing 50 by 5 gives 10. Continuing on, there are no other common factors to cancel, so 10 times 16 is 160, and 1 times 3 is 3. As I've said before, this solution is perfectly acceptable, but we can change it into a mixed number or a decimal number. 3 goes into 16 5 times with 1 left over, so 3 goes into 10 3 times with 1 left over, so that would give us 53 and a third. If we change that to a decimal number, that'd be 53.3. We could round it to that, or more accurately use the bar notation to show that that number goes on forever. In problem number 8, we have 4 times x divided by 9 is equal to 30. What we're going to do is multiply, in this case, each side by 9. This is using the two-step method. On the left-hand side, the 9's cancel out, leaving us with 4x on the left of the equal sign. And on the right of the equal sign, we have 30 times 9, which is 270. Next, we will divide each side by 4. On the left-hand side, the 4's divide out, leaving us with 1x being equal to, and then 270 divided by 4. Well, we could reduce that fraction by a factor of 2. 4 divided by 2 is 2, and 270 divided by 2 is 135. So that could be our one answer, 135 over 2, or changing that to a mixed number. 2 goes into 13 6 times, with 1 left over. 2 goes into 15 7 times, with 1 left over, so that'd be 1.5, or 67.5. This has been solving one-step equations with multiplication and division by me, Mr. Pi the Math Guy. Let me tell you this, solving equations with multiplication and division is very easy if you use the properties of equality to maintain the balance in the equations. I showed you 2 methods to deal with fractional coefficients. If you found this video useful, leave a comment. If you didn't find it useful, leave a comment too. I enjoy all kinds of criticisms. Thanks for watching. Bye-bye.